get a chance to introduce Peter Lee. Peter Lee and I go way back at Microsoft. We worked together for many, many years. When Peter came on board at Microsoft to head up a lot of our research activities. Since then, Peter's role has only sort of scaled in many dimensions kind of thing. Currently, he's the corporate vice president at Microsoft, running a variety of what I call research and incubation efforts in a wide variety of areas, spanning healthcare, spanning security, and data science. I'm really excited, and I hope you're all excited as well, to hear from Peter, his perspectives on what's going to happen with intelligent applications, where do we see intelligent applications moving, and more importantly, what the future of foundation model is going to be that's going to power the next generation intelligent applications. Once Peter finishes his keynote, he's also going to be moderating a panel conversation with a bunch of great people, including Justin Borgman, who's the CTO and chairman of Starburst, Anu Sharma, who's the head of products at StatSig, and Alex Ratner, the CEO of Snorkel. Now, that conversation is going to primarily be a deep dive into the core set of technologies and trends that are powering the next generation of data-driven intelligent applications, and both listening to Peter's perspective, as well as listening from this panel of people. I think it's going to be an exciting conversation. Thank you for coming back on time here. Peter, please come on stage.
I don't. Wait. Wow, thank you. And it's really fantastic to be here. And when I was asked to come and moderate the panel, that seemed great. And I'm actually really looking forward to the chat with Justin and Anu and Alex. But then I was asked, on top of that, could I talk about what enables intelligent applications? And my bad joke always in response to a question like that is, when you figure it out, please tell me. And in fact, it's a question that is actually very important because there is a here and now element to it. But the field of machine intelligence is just moving so fast right now that we don't actually have clarity on what things will be like 1 year from now or 10 years from now. And so I thought I should just change the title of the talk to be what will intelligent apps become in the future? And it's really a question. I'm afraid I don't have crystal clear answers, but I do have some framing. I want to start just by saying, man, there's a lot of hype out there. And there's an irrational exuberance. It attracts a lot of capital. Microsoft, where I work, is not above exploiting that hype. It helps our business just like all of yours. But there is something about artificial intelligence in particular and about machine intelligence that just really inspires imagination, really allows us to fantasize about value creation. And it goes overboard often. I'm looking at Oren Etzioni, and Oren and I have had multi-hour conversations on that topic specifically. At the same time, it is also true that the field is advancing more rapidly than people can really understand, than the general public and even the investment community can really understand. And that the advances bring us to a place that may be well beyond people's current imagination. And so we are in this very odd situation where we have a combination of hype and also dramatically underestimating the true impact and the true kinds of applications. A thought experiment that I always challenge people with is, if someone gave you a brain in a box, if someone gave you GI in a machine, what's the first thing you would do with it? And it turns out to be a harder question to answer than you might expect. And it's fundamentally the question I think that many of us are trying to grapple with here. So just to make it a little easier to talk about, and then for me to pose my question about what do we think intelligent applications will become, I thought it would be useful just, first off, just to ground ourselves in how we talk about intelligence. And what I'm about to say is just, third grade level, especially for a room like this. But I'm finding increasingly, as machine intelligence becomes more and more pervasive and more real in the world, touches more lives, it becomes important to really have a way to explain what it is that we're doing. And so, we talk about intelligence. We don't really know how to define intelligence. We believe we know it when we see it. But we talk about this thing. We talk about intelligence as something. And then when we talk about artificial intelligence, we think about artificial intelligence as the study of machines that exhibit this undefined thing called intelligence. And since we're not able to define intelligence fully yet, we're not really able to come to an acceptable or precise definition of artificial intelligence. Here I've drawn artificial intelligence as being contained entirely within intelligence. That's probably sensible, but if we think of intelligence as uniquely human, we don't know if artificial intelligence is contained within intelligence, human intelligence, or if it's something that goes beyond. We don't know if it's finite. We really know very little about it, but it's an academic and scientific study. When we hear people like us in this room talk about artificial intelligence to our customers, to our investors, to our bosses, what we're generally focused on 99.9% of the time is what presumably is a tiny slice of this field of artificial intelligence called machine learning, which is, at least in academic terms, the study of machines that improve with experience. And in fact, when we talk about AI, we're actually saying machine learning. And when we talk about machine learning, we're actually not even talking about the entirety of machine learning. We're generally speaking talking specifically about the tiny subset of the field of machine learning where that notion of experience is data. And typically that data being the digital exhaust of human thought and activity. And so part of the reason that we see so much hype is the idea of intelligence is such a big thing, but in fact what we're talking about, what we're developing, what we're selling, what we're trying to understand ends up being a very small slice of this idea of AI. Now, of course, just saying it's small doesn't mean it's not valuable. It's incredibly valuable. And there probably is decades of value to be mined just from that little orange dot. Lots and lots of examples. I already, just in the last half hour in this room, have had quite a few conversations about some really fantastic applications of this notion of intelligence. I just pulled a random one out from this morning. I had to do some HR work at Microsoft, and it's nice that there's intelligence there that helps kind of co-author reviews of my coworkers or my team's work. But it's still this very limited slice of things. And so the thing that I think has been animating and creating this frenzy of activity and intensity and pace in artificial intelligence today has been a shift from a dependence on data to self-supervised or largely or weakly supervised approaches to learning. And this idea has just, over the past 4 years, just accelerated to the point where, well, it's crazy. Academic research now, just to keep up, you have to keep up on Twitter, not on the major conferences or archives. And I personally lay the blame for this frenzy on the Allen Institute for Artificial Intelligence. Because at least for me, where I ended up developing a frenzy on this, and many of you have seen this graph, it seems to have, this is, I think, my first PowerPoint slide that ever went viral on Twitter. But in 2018, the Paul Allen Institute for Artificial Intelligence published a paper with this mega large language model with, I think, almost 100 million parameters called ELMO. And what was so interesting about it to me was the idea that we might be able to actually learn something about the structure of human language and maybe even human thought in a largely unsupervised way. Fantastic. It was also very interesting to me that this came out of all places, the Allen Institute, not for lack of the intellectual depth and power of that research institute, but it had always been an institute that had staked out a position more in the realm of common sense reasoning and really understanding human thought at a more abstract and symbolic level. And yet here was this thing that was just blindly grabbing text out and in an unsupervised way, trying to discern some structure. And it wasn't just me. Just this kicked off what I would call a kind of arms race between several major tech companies. We have the BERT and T5 out of Google, GPT-2 and GPT-3, GPT 3.5 out of OpenAI. OpenAI and Microsoft together on continuation of the GPT program and the Turing effort within Microsoft. And this is somewhat of an old slide of the public disclosures of parameter sizes of models so far. But I think it's well understood that at these organizations and a handful of others, things have gotten much, much larger. While we can't talk too openly about why these organizations would take on the expense and technical risks of this kind of extreme scale, we should probably assume that there's enough financial discipline in these companies that is being won over through an observation of the emerging capabilities coming from these large language models. Already, just to speak within Microsoft, but I'll bet there are 5,000 other applications that are just brewing around just out of this room or out of your distance one professional networks. Just to take a few examples just out of my neck of the woods at Microsoft, we've made a transition for all of our text analytics for health to large language model foundations. And what has been shocking to us is that we've not needed any specialization or fine-tuning to be able to take unstructured medical notes and discern structure from them. We went through, a couple of years ago, the acquisition of Nuance Communications, and their most important new product is something called Dragon Ambient Experience. And Dragon Ambient Experience now is built on two large neural transformers, one that does the speech recognition and diarization, and the other that generates automatically the SOAP medical encounter note just from listening to doctor-patient conversation. Again, it's just really incredible, the flexibility of these models in being able to do this, to be able to be responsive to a doctor's review of the form of the SOAP notes to fit that particular doctor's style of work. And it's not just text, but of course, code. Within my organization, our GitHub division, of course, a few months ago, released for general availability Copilot. It has created kind of a frenzy of activity just in the increased amount of automatically generated code that our researchers and software engineers are developing. And it's also created new questions about the nature of what's going on here and the understanding of the broader context of a larger piece of software. And as it started to raise questions on top of that about going beyond just code writing, but understanding the entire software engineering lifecycle and the placement of this type of intelligence throughout that lifecycle. And then these things are no longer just text, but in fact, images and in some cases video are also now being embedded in the same vector spaces not as separate models, but integrated in the same vector space, along with an understanding of the structure of language. And that means that when you use, for example, our browser, but we're not unique in this, there is a broad understanding of the content of the page that you're looking at that is used to inform, in this case, better super resolution of images. And so this sort of integrated intelligence is just appearing in more and more places. And in fact, within Microsoft today, by last count, there are about 120 product features that are now being based or powered by some large foundation model. And so it's just becoming an incredibly flexible tool as we move on and the capabilities of these things get better, and as the cost, the inference costs of using them become lower. So what does this all mean then for enabling intelligent applications? And I want to say again, the heck if I know. But here's the question that I would ask. If we think about practice today around machine intelligence, around machine learning and the integration into applications, roughly speaking today, everything starts with data. And in fact, we're going to see some great companies here on our panel where the primacy of data and the ability to actually extract and transform and prepare aggregate data for machine learning in order to create those specialized models to power intelligent applications becomes extremely important. And it's really the first major friction point that has to be solved by any organization that wants to create intelligent applications. But we are now seeing, and I hope I've convinced you, at least within the Microsoft context, but I'm sure we're not alone on this, that we're starting to shift into a world where it's less about building lots of different specialized models and all of the MLOps complications that entails, and instead, everything starting from some foundation model and then thinking about how best to do fine-tuning or specialization. There's still an MLOps issue, there's still an ETL issue, but it's at a different level, and it's somehow kind of more less full of friction. But moving forward, when you look at the scale, there's a possible future that could be very different. What will this be like a year from now, 2 years from now, 3 years from now? Well, our largest language models today, at least within Microsoft, but I think you could probably go over to Google or to Meta or to Baidu and other places, are getting surprisingly good at a broader range of applications. And so again, just in laboratory, one example is to be able to take medical research papers. So here's an example. And then after having the model read those research papers, allowing you to ask detailed questions and have answers to those questions that are deep and apparently well-reasoned. And in some cases, for example, if you read this particular paper and ask this second question, can baricitinib suppress ALK activity in lung cancer with a different genetic fusion? These are ideas that actually aren't expressed in the paper themselves, and yet we're finding it increasingly surprising the number of times that these language models at scale are able to somehow stitch together the reasons in order to provide an answer. And so it goes, as we saw before, not just to language, but to images. It also goes even to 3D structures. What you see here are side-by-side videos of a chemically precise molecular dynamics simulation of a protein called, I forgot the name of the protein, and signalin. It's not the most complicated protein in the world, and also this molecular dynamics simulation is a little bit artificial in that it's a simulation in vacuo, so there's no solution like water or something that it has to interact with. And this was part of the KDD Cup Challenge last year. And it's a great challenge for molecular dynamics simulation because on a normal supercomputer and using classical simulation codes, it's estimated that this would take about 1.1 million years to get a complete fold of the protein. And yet, what you see here on the left is a complete fold. And a complete fold that maintains the chemical precision and represents an acceleration of about 10 million x based on the use of an extremely large, in this case, graph neural transformer called a graphformer. And so when we think about the possibilities of being able to simulate physics and chemistry and biology at that scale, the number of applications just seems to grow even further. And so it's now not even just the question of what enables intelligent applications, but what could those applications be in this new era. And so when I think about the future, the question I ask is, are we moving at some point towards a future where everything starts from maybe a very small number of foundation models, maybe in the limit even just one? Is there one brain out there? I know it sounds crazy, but think about the trend line. And that this then becomes a world which is less about data, less about fine-tuned models, less about specialized models, but instead more about the context of use by each application or each user. This is a crazy drawing by Dali too, but when you think about a world like that, it really brings up the nature of the partnership between humans and AI systems. And so I'm hoping to be able to challenge our panelists with this sort of vision of the future. And so I will bring them up right now. So if Justin, Anu, and Alex can come up and join me. If you have questions about my presentation, please hold them. We will also have questions for the panelists, I'm sure. So I'll try to reserve time at the end of our panel discussion. So thank you very much.